This lesson is about absolute value functions and how to graph them. First off, let's remember about functions. We said a function was like a machine that took some number that we put in, and normally we called that number that we put in x. And it did some math to it, ka-chunk, ka-chunk, and it spits out some particular value. We called that value that it spits out f of x. That's the value that the function f spits out when what we put in was an x. Sometimes we also track that value f of x, we call that the output variable, or y. In this case, what we want to look at is what happens when the function that's inside this box, the equation for what we do to that input variable, includes an absolute value. So suppose, for example, that a particular function simply takes the absolute value of whatever we put in. Let's track for a minute now some numbers that we put in to our function, and we'll keep track of what happens to the function, and then our output variable, f of x or y. So in this case, if I plug in x equals 3, the value of the function when I put in a 3 is the absolute value of 3. The absolute value of 3 is just 3. When I put in a 2, the value of the function when the input is 2 is the absolute value of 2, which is just 2. We're starting to see the pattern here. When I put in a 1, I get out a 1. When I put in a 0, I get out a 0. Things change a little bit when I start to put in negative numbers. Let's say that I put in a negative 1. The value of the function when we put in a negative 1 is the absolute value of negative 1, which is just 1. Now notice that two different input values, 1 and negative 1, had the same output value. This is still a function because it's not like there was a case where I put the same number in twice and got different things out. So if I put in a negative 2, the value of the function when I put in a negative 2 is the absolute value of negative 2, which is 2. What I can do now is I can take these combinations, these input-output pairs, and I can graph them. So we'll make for ourselves an x-axis and a y-axis. Notice that when x is 3, y is 3. So the point 3, 3 is on our graph. 1, 2, 3. When x is 3, y is 3. 1, 2, 3. So this point here. When x is 2, y is 2. When x is 1, x is 1. When x is 0, y is 0. Now if we think about it, these points seem to fall on a straight line, and it seems to make sense that the straight line is going to continue off infinitely. Because when x is a positive number, whatever number I put in for x, I get out the exact same number for y. What happens though when the x's were negative? When x is negative 1, y is positive 1. When x is negative 2, y is positive 2. When x is negative 3, y is positive 3. It looks like when the x's are negative, the y has the same magnitude, the same number part, but the opposite sign. So this is a graph of the function y equals the absolute value of x, and it has this weird V shape to it. Let's see then what happens when we have functions that are more complicated than simply the absolute value of x. So the next function that we're going to look at is a slightly more complicated function. We'll take an input, x, and our function machine this time is going to take the absolute value of x plus 3 and spit out f of x, also known as y. So let's see what happens when we plug in some different numbers this time. What if we plug in 1 for x? F of 1, that is the value of this function at 1 then, is the absolute value of 1 plus 3. 1 plus 3 is 4, and the absolute value of 4 is just 4. We can repeat this process a couple of times. Let's try 0. The value of the function at 0 is the absolute value of 0 plus 3. 0 plus 3 is just 3, so this is the absolute value of 3. We notice in this case we can put in negative numbers for x. The value of the function at negative 1 is the absolute value of negative 1 plus 3. Negative 1 plus 3 is positive 2, so we're taking the absolute value of 2, which is just 2. As we continue on, we'll find that the absolute value of negative 2 is 1, the absolute value of negative 3 is 0, and you could do the work to see this. The absolute value of negative 4, let's take a look at that. The value of this function when x is negative 4. Now we're taking the absolute value of negative 4 plus 3. Negative 4 plus 3 is negative 1, so we're taking the absolute value of negative 1. The absolute value of negative 1 is 1. So notice that this function seems to turn around. That point in the v happens at a different location for x. It happens when x is negative 3. So let's say that we take these points and plot them on the same graph as we had originally plotted y equals the absolute value of x. I'll plot these points in green so that we can tell the difference. So the first point on this function is 1, 4. 1, 1, 2, 3, 4. When we plug a 1 into this function for x, we get a 4 out for y. 0, 3, negative 1, 2, negative 2, 1, negative 3, 0. And now this point is where our function seems to turn around. When x was negative 4, y went back to positive 1. If we plugged in a negative 5, we'd see that we got out a positive 2, and the function would continue. So it looks like in this case, this change to our function, where we added 3 inside those absolute value bars, it looks like it took our whole function and it shifted it over to the left by 3. Let's see what happens then when we have some other changes to this function. Here's another function. This function is f of x equals 2 times the absolute value of x. Let's plug some different numbers in for x and see how this function behaves. When we plug in a 2 for x, the value of the function when the input is 2 times the absolute value of 2. The absolute value of 2 is just 2, so this function is 2 times 2, which is 4. Next, let's plug in a smaller number, 1. F of 1 is 2 times the absolute value of 1. That's 2 times 1, which is 2. When we plug in 0 for x, f of 0 is 2 times the absolute value of 0. That's 2 times 0, which is 0. When we plug in a negative number for x, this is where our function is going to turn around. F of negative 1 is 2 times the absolute value of negative 1. The absolute value of negative 1 is just 1. So the value of the function at this point is 2 times 1, or positive 2. Here's where our function has turned around. Let's add this one onto our graph as well and see how this changes. So in this case, when x is 2, y was 4. 1, 2, 3, 4 here. When x is 1, y is 2. When x is 0, y is 0. So it seems like what we have here is a steeper line. That 2 out in front of the absolute value seemed to make this line become steeper. So this is y equals 2 times the absolute value of x. Now it turns around at the same point. It turns around where x goes from being positive to being negative. When x was negative 1, y was positive 2. And up we go like this. So we can see that putting a number out in front of the absolute value bars changes the shape of our graph. It changes how skinny that v is. Last but not least, let's take a look at what happens when we add or subtract a number outside the absolute value bars. So in this case, our function is going to be f of x equals the absolute value of x, and then add 4 to that answer. So let's start by plugging in maybe 0, and let's see if that's an interesting number for us. When x is 0, the absolute value of 0 plus 4, well, the absolute value of 0 is just 0, and 0 plus 4 is 4. Now let's try a positive number. When x is 1, the absolute value of 1 plus 4, the absolute value of 1 is just 1, so 1 plus 4 is 5. Now let's try a negative number. The absolute value of negative 1 plus 4, the absolute value of negative 1 is 1, so 1 plus 4 also equals 5. So what I've noticed here is that right away I found that point where our function is going to turn, where the bottom point of that v is going to be. So let me try a couple more points to get a sense of the general shape of the graph. Let me try x is 2. The absolute value of 2 plus 4, 2 plus 4 is 6. And negative 2, I'm predicting that this is going to give me the same answer as positive 2 did. The absolute value of negative 2 is 2, plus 4 is 6. So let's add these points to our graph and see how adding 4 outside the absolute value bars change the shape of our graph. So here are all the graphs that we already had going. Let's see. When x is 0, y is 4. 1, 2, 3, 4. And remember, this was the point on the v of our graph. When x is 1, y is 5. When x is negative 1, y is also 5. When x is 2, y is 6. When x is negative 2, y is also 6. So it looks like in this case, it looks like adding 4 outside the absolute value bars took our original graph, which was this one here in black, and it looks like it shifted it up by 4. So adding a number inside the absolute value bars shifted our graph over. Adding a number outside the absolute value bars seemed to shift our graph up.